Hello, folks. I'm Maciek. So far, we've been talking about one half of our job, about writing features. Now we'll be talking about writing bugs, and specifically, some bugs are just harder than the other ones, right? Have you ever been there? You sit at work, starting in the code, and that doesn't work. And you're stuck because you've changed every code path twice, and it still doesn't work. Or you debug as a team, and user reports for the 10th time that it doesn't work, and nobody cares that it works on your computer. And then a guy with a hero complex arrives, saying, "I know!" And he disappears for 2 days, returning with 1,000 lines of changed code. You deployed it to the production with high hopes, and yeah, it doesn't work, right? And then the worst happens because people start venting off, right? Everybody's frustrated, so you start looking for a scapegoat, maybe in your team or maybe outside, right? So the bug becomes a hot potato. If you are in a bigger organization, like I was, you basically think, okay, I can't fix it, so let's reassign it to the other team. And after a week, this bug returns to you, right? Yeah, that happens. And at the end, your manager comes asking, "What have you been doing for the last week?" Debugging. "So how many bugs have you fixed?" None. Okay. Yeah. I think you have been there, right? Because my question should be not, have you ever been there, but how many times you have been there, right? Because I heard it's a conference for senior developers. I always highly regarded this conf because of this. So yeah, how many times have you been there? I have been there numerous times because I've been in Ruby development over 10 years. And right now, I work for an application that has terabytes of database of data in database. We orchestrate a dozen of machine learning services. It's awesome, but it's also complex. So it's very easy to get stuck in some weird bugs. And it's just the last year. What about the previous 10 years, right? Yeah, I have been there. And I must say that when you are there, you start questioning your life choices, right? Maybe maybe anybody was studying here in this room? Hands, show of hands. Yeah, that's the moment when you think, maybe I should go to the other side of this building and become a journalist, right? Or maybe when I get stuck on this kind of bug, I think, yeah, I can still work remotely. But for me, working remotely should mean working from remote parts of Polish mountains as a shepherd, not working remotely from my desk. Yeah, you've been there. I see it in your eyes. But I haven't switched my job. I'm still a developer. I used to be a principal. I used to be a team lead. Now I'm just a senior developer, but the company is awesome, so I stay there. And I bring you hope. I want to share with you a method that is very effective for me. That's a way out of the debugging hell. And I'm here mostly because I've seen it used, I've seen it applied by other developers, other than me, independently. So I noticed, yeah, I use this highly effective method, and they use it too, even though I didn't tell them. So it means it's good, right? I want to tell you to start debugging like a scientist. I work for a company called Chattermill. I told you that's the moment of introduction. 10 years of experience, I told you. Ruby development, I told you. Yeah, let's move on. I'm not a scientist, so why should I tell it to debug like a scientist? And moreover, sorry, David, now a bit of grilling. Why should we debug like scientists? They are weird, right? They are highly impractical. they don't know anything about bugs, because what they do, they coin some weird theories, they write boring papers nobody wants to read, and they spend public money that could have been spent on, I don't know, trains or highways or, I don't know, kindergartens. So why should we be like scientists? Nobody knows. So I'll tell you, let's get back to the end of 19th century, when the physics was in kind of split state, split brain state. On one hand, physicists thought they got it. They understand the world. It was a nice feeling. On the other hand, they were in a state of a small crisis regarding the light, the speed of light. They knew a lot about the nature of the light. They knew it's both the wave and particle. They were able to measure the speed of light, which is wonderful. Still, they thought that the light to propagate needs some kind of medium, just like sound needs a medium to propagate, right? So they proposed a hypothesis of luminescence ether, that is unmoving medium that light is using to propagate, and it's all around in the space, because we can see the stars, right? So they thought it would be nice to measure how fast, what's the speed of Earth relative to the luminescence ether. So Michelson and Morley in 1887 proposed this very smart experiment when they sent 2 rays of light in orthogonal direction, and then they want to measure the speed difference, right? Because based on the classical physics, the classical Gaussian transformations, this speed should be different. And they measured it, and the speed was the same. It was a surprising behavior of the reality. This kind of surprising behavior of the reality in computer science we call a bug. Yeah, and surely they were bugged. So what they do? They did the same as we do. They patched it. They proposed some ad hoc theory, some ad hoc hypotheses that were rather weak and didn't work. And this crisis went on until a young clerk from a patent office arrived, writing 2 papers, 2 boring papers that nobody reads. And one important thing is that Einstein decided to describe the reality instead of yelling at the reality. And he said, okay, so from the observations and from the theory, I can say 2 things for sure, 2 assumptions, that the laws of physics are the same in every frame of reference, and that the speed of light is independent of the state of motion. He started with those 2 assumptions, and then he was able to deduce what we now call the length contraction and time dilatation. And he was able to deduce the Lorentz transform that you can see on the bottom. It was known there, but it wasn't well grounded. And yeah, it was just a hypothesis. It was a weird theory, but some younger guy that nobody knew. But then physicists started to make experiments, and experiments confirmed this theory. That's something that we call special relativity. At least at my times, it was something normal to learn at high school. It's not a rocket science. It's a high school physics. Weird, but still. So what happened here? The results are less important. The method is important. Physicists saw a weird state of reality that was surprising. So they guessed how to explain it. They formulated a hypothesis. Then they proposed some experiments. They made predictions, and they made experiments to confirm or reject it. And for the first hypothesis, the luminescence ether, they had to reject it. But for the second hypothesis I told about, for the special relativity, they kept it. They verified it. And that's how physics goes forward. And that's something I believe we can apply. But still, you can ask. It was a cool story, bro. Let's go have a lunch. But now it was the simpler part, because I have no emotional connection to Mr. Einstein or to crisis in physics, but I do have emotional connections with the war stories I'll be telling about. And if somebody starts shaking, there are some survivors in this room, I believe. So let me tell you about the first one. We had weird errors in our integration testing suite, in our Cucumber suite. Who loves Cucumber? Show of hands. Yeah, it's stable, right? It never breaks. We were optimizing a GraphQL API. And we introduced a library to preload SQL, to preload data from the database. And this library started raising errors. Those errors were rather shameful, because we were calling a method that didn't exist. So it was serious. And in front of our door, we had an angry mob with pitchforks yelling, "Remove the gem, remove the gem, remove the gem." Fortunately, I was working remotely, so it was virtual mob with virtual pitchforks, but the yell was real. We removed the gem. And we didn't want to, because it sped it up, and we were able to deliver on time, so we really needed this gem. So we started investigating, and we noticed, we started reading the source code of the gem, and we noticed that everything should be all right. It works on my computer, right? Because we have this special configuration constant that is used in the God statement, but the bug happens below that, right? So we could start yelling at the reality, saying, "It's impossible, it's something." It didn't happen. It doesn't happen, yeah. But unfortunately, it did happen, and the pitchforks were virtual but dangerous. So we dug deeper, and we realized that indeed we changed this configurational variable in a before filter, but then we changed it back, so everything should be good. And that was the moment that I started staring at the monitor, thinking, I know it. I have seen something like this. And I thought, yeah, I guess it might be a race condition. It's not that I've seen it too many times as a Ruby developer, but it looks like a race condition. It's my wild guess. I need to verify it now. The stakes were high because I was promised a PhD. I'm still waiting for a diploma. But, you know, I lied a bit. I wasn't guessing because I'm a software engineer. I'm a professional. It wasn't a guess. I formulated a hypothesis. And for this hypothesis, I had some supporting evidence. The supporting evidence was that first thing is that this before filter changing the configuration was introduced around the time when the CI problems started to happen. That was good. And the second thing was that we were using Puma for integration tests, and we had threading enabled in Puma. So yeah, it was possible that it was a threading problem. So I tried to experiment, and the first experiment with threads failed, but it wasn't simple enough. So I decided to do something simpler, and I simulated threads. I wrote a script. The first one, the first part was with the business logic, those 3 lines, this business logic that could raise an error. And then I interleaved it with the before filter and after filter that could run in another thread, but I interleaved it manually, like line by line in the same script. I ran it, and wow, we failed successfully. We confirmed that it is possible, that it is because of the race condition. So we had a good reason to revert the pull request that introduced this race condition, and the problem was removed. Fortunately, it was introduced by another team, fortunately and unfortunately, because in normal case, we would go to this team and say, yeah, it's your fault, try to fix it. And they would say, no, it's your gem, try to fix it. And here we had a very strong evidence saying, the gem is okay, guys. It's the change that you made. That's not 100% robust. Please fix it. And they did, and everything was good. It wasn't a hot potato. It was a well-described bug that can be fixed. So what happened here is that we started with some observations about the guard variable, about the place of the error. Then there was a wild hypothesis that it's race condition that was verified with a very simple experiment that allowed us to understand the reality, to describe it correctly, and propose a fix. You know the state. The bug is fixed not when you push something to production very often, but when you understand what happens, right? And what also happened is that we started with gathering data, with observations, a bit in the lab, a bit in the library. We verified, we proposed a hypothesis, we verified it, and then we got to the understanding. It looks like a scientific method a bit. I proposed the name hypothesis-driven development because it looks good, and you can write a book with something driven something, right? And yeah, it worked, but it was a simple case, right? I was able to debug locally, but sometimes you can't debug locally. Sometimes the code fails only on CI. So what then? Yeah, you should have reproducible CI environment locally, right? Everybody does. This time we weren't able to reproduce it locally, but only this time, right? And again, it was about Cucumber, and we had a distributed environment, several services. Everything was orchestrated with Docker Compose. And the setup of the Docker Compose was failing from time to time with some ugly errors about the timeouts or about that suggested that something doesn't work in the infrastructure. So I started digging because, yeah, we needed it to work. We needed this to work badly. And I thought, yeah, maybe it looks like a timeout. So maybe it's when we push the data to the GraphQL gateway. So maybe we push too much. That was my hypothesis. So let's try to make a lighter request. And instead of doing a huge post, let's try to do a head, simple head. And what happens and puts the results, because I'm a puts debugger. And there was a retry, and at first it was 404, but and the second try, it was reads timeout. I thought, oh, reads timeout, it's different. I put it in my notes. It's different, it's weird. What is a reads timeout? What's the difference between various timeouts? I don't know. So let's read around, let's get back to the library. And I found a piece of documentation explaining the reads timeout and that it's different from the open timeout. And I thought, okay, so it's a reads timeout. It means that the container is started. The process is probably started because the port is opened, but the process doesn't react to my request. That's weird. Let's put it in my notes. I don't understand it, but let's dig around. So I was Googling another day, and I found out in Docker Compose issues that somebody had an issue that a container froze. And it was because of excessive logging and some weird configuration state in Docker Compose. I thought, yeah, it looks similar, but I don't know. Yeah, but we log a lot. We have a health check that logs a lot, like a crazy. So let's make a hypothesis that it's because of logging. It's weird, but maybe. And the simplest possible experiment, let's disable the logging for the health check, and let's see what happens. And it was fixed. So again, it's very easy. It gave us the understanding it's because of the Docker Compose. It's very easy to blame the dependency, right? It's this next level of hot potato. It's not us. It's the infra. But this time, we knew very well. It's not generic infra. It's because we have too old Docker Compose that has this weird error. Infra guys, please upgrade it for us. We had a very good way to saying this. And you can see we started with some random observations. I was taking notes for everything, and I understand very little. I connected the dots, saying it might be a bug in Docker Compose. I made a simple experiment. I didn't break anything, but I guess I had to push it to master. And it gave us the understanding. And we were more than halfway there when we reached here. But still, it was a simple case. It was one team debugging. It wasn't very urgent. It was just urgent enough. But there was another case, the last one I'm going to tell you about. It was disgusting. It was shameful. And it was embarrassing because production was failing in a regular cadence every 30 minutes, and we had no idea why. We saw those 502s, our business saw 502s, our clients saw 502s, and we didn't know why. I joined the working group trying to fix it, collected from various teams, or rather a task force. I believe some veterans of this task force can be in this room. Give them some comfort. And we were trying to understand what happens. And we had a lot of hypotheses. Maybe we have an application level cron, a clockwork, that every 30 minutes does something. Or maybe we have an infrastructure level cron that does something low level, like, I don't know, log harvesting that kills our disks or our network. Or maybe we have a client that sends us slow requests every 10 or 30 minutes, or another service in our environment sends this slow request or a bunch of slow requests. We had a lot of hypotheses, and the work was going in parallel. And it was the moment when I understood that the method that was very convenient for me, working with hypothesis experiments in a repeated manner, was used by my colleagues that were definitely smarter than me. And I thought, yeah, that's a good method. I should tell somebody about it. So we were working like this, and with little progress, they passed. We were more and more embarrassed. There were no simple solutions. But we had some observations. First of all, somebody noticed that it's just a single node at a time. It's not that the whole application stops. The error is risen by just a single node. So we had a hypothesis that it's some kind of stabilizing up. It's rather obvious, right? Some people started checking the database load balancer. My hypothesis was that it must be a memory leak, because a couple months back I was debugging memory leak and it stayed with me. And yeah, there was a memory peak around the time of the errors. And I started taking notes, trying to correlate what we have. One important detail is that we were seeing the problems in Grafana because we had a metric of the length of passenger queue, and when the request queue was growing like crazy, like you can see here, it meant that we have the problems. And that was the symptom. So I was taking notes. Okay, when exactly the problem starts? Okay, it starts at 10:20, then the queue saturates in about 4 minutes, and then it drops. And after half an hour, it happens again. Okay, I understand a bit. So I correlated it, and I noticed that the first timeout happens before the state buildup in the passenger queue. So yeah, that's curious. So it's just the symptom. And the memory peak is not before the buildup, but after the buildup. So it's not a cause, it's an effect. And I sit down to work on it late evening. It's a bad practice. Never do this, please, please, please. But I did it because I kept it in my head. And I added some more stats to Grafana because we weren't showing everything that we had from passenger. And I noticed a curious thing. It's too small probably. The yellow chart is number of processes in passenger. That's decreasing. And below this are spawn events, when passenger spawns a new process. So I was staring at this thinking, so the number of passengers, number of processes drops. Why? Passenger kills processes, but it should spawn new processes, right? Maybe they are not killed in the right way, yeah? Why do we spawn new processes so rarely? I don't know. So what I did, I put a note on Slack and I go back to bed. And I went back to bed. Those are rather questions and answers. So I put my observations and I said, yeah, so I don't understand why new process is not started. I don't understand why the build-up happens on a certain threshold. But I do understand that I was wrong. It's not a memory leak. And when I returned to work the next day, I saw some answers because a guy from Argentina was working later and picked up what I left and gave some answers. So he noticed that there are some error logs in passenger saying that passenger gets timeout on start and that enters a deployment resist mode. That's a special feature of passenger that if something bad happens on startup, new processes are not started. And it was the explanation why the problem happens. So we started gathering what we have. Yeah, so it's just in one instance. It's a localized problem. We have the passenger resist mode. We understood it. We understood very well how passenger process model worked. I didn't know before. So we also noticed that when a new node was started, the problem didn't happen there. So it was really a local problem. And somebody noticed that we have a huge Bootsnap cache. Do you know Bootsnap? It's a Shopify gem that helps you start your Rails processes faster because it's caches a lot. But when this cache reached, 10 gigs or 16 gigs, reading the cache was so slow that passenger was timing out on startup. At least that was our hypothesis. So what was the simplest way of testing it? We removed the Bootsnap cache and we hold our breath because the problem stopped appearing, but it meant nothing. Maybe it reappears in next half an hour, right? But it didn't. And after a day, we got to the understanding that it was the Bootsnap cache that was the problem. So how come, right? It's a good gem. So the history, we need to get back half a year before when my team upgraded the Bootsnap gem. And maybe I was even reviewing this, but it was, a number change, small upgrade, it's okay. But with the small upgrade came a change in config, and Bootsnap started keeping the cache in different directory, and we didn't change our deployment script. So the Bootsnap was adding stuff to the cache, but we never cleared it. And after half a year, it got to this 10 or 16 gigs, and it started kicking us really. So all the classical methods, also revert the last deployment or check the code changes for the last week, we didn't have chance, right? But there is one more important thing, that it was a stupid error, right? And there is an important thing. It showed me how to scale debugging effort. It's easy to debug as a single person, but what about the whole team, right? We were able to follow multiple paths of inquiry without blocking each other because we have multiple hypotheses and we tested many of them in parallel. Also, we were working in small teams on a single hypothesis because very often one person had an idea. It might be something with the database load balancer. A developer could say this, but he needed an infra person to really work with the load balancer and to verify it. We were also to work round the clock, not because we were tied to our keyboards, but because we were spread geographically, and the next time zone was able to pick up what we prepared, right? And next, it was possible because we didn't have this hero problem. We were publishing every small piece of evidence, every small observation, every small hypothesis, so that we were able to work. We were standing on each other's shoulders, right? What was required was that it was a kind of a safe space where we knew that it's about fixing the problem, not about being a hero, and we work as a team, and we will be rewarded in one way or another. And also something that might be important for you if you want to pay attention for 30 seconds. That's this moment. It's a great way to work with junior team members. If instead of saying, "Yeah, you are too dumb to fix it, let me debug it," you say, "Okay, so you're debugging this, and you seem to be stuck, right?" "Yeah, right. So what's your hypothesis?" "Oh, okay. What's your you don't have a hypothesis, but what's the weird thing that you observe? Let's write it down, right? Let's write down what the internet says about this behavior. Okay, so what's your hypothesis now? How to connect the dots? And then how to verify it? Okay, but you need 2 days for this, right? Right. So let's find a simpler way. Maybe let's verify it in the next 2 hours. And then, okay, it's not this. Or, yeah, it's this. We understand it better. So maybe we can fix it. You can use the Socratic method, working with your junior team members or with your peers to help them grow, instead of being the guy that says, okay, I'm the hero, I'll fix it. That's the better way of scaling your efforts. And do you remember where we started? With that frustration, being stuck with debugging and thinking about working remotely. There is a way out, and this way out lays in science. But it's not about scientific results. It's about looking at the way the scientists work and trying to apply this method of working to our daily practice. And it's more than just proposing hypotheses. It's also about good practices, starting with the mindset. So when you arrive at the problem, don't jump to solution. Don't be a guy with or a girl with a pitchfork yelling, remove the gem, revert the last commit. Because without an evidence, it's just your opinion. It doesn't matter if somebody saying this is an architect, a manager, a CEO. It's just his opinion or her opinion, and it's not actionable, really. It might be a good way of proposing a hypothesis to experiment, but not something really actionable. Then it's about habits. The crucial habit for me during debugging is taking notes of everything, and when I don't understand, asking questions in the same notes. It's the local way of rubber duck debugging, and also it's a great way of being focused even during the interruptions. For sure, you've read the hundreds of blog posts. You cannot interrupt the developer at work because he will be removed from the state of flow, and it takes half an hour to get back, right? Rubbish. It's rubbish, folks. We can't get back to the state of the flow. We can't rebuild the mental state because we are very bad at taking notes. With the notes, we are far faster to get back to work, and interruptions is our daily life. So let's accept it instead of yelling at it, right? And next thing, there are 2 types of developers. One can spend a month in the library just to avoid doing anything in the workshop, in a lab. And the other one tries to fix the code for a month instead of reading how it works for 1 day, right? Be neither of them. Balance this, because those 2 practices really help each other to make debugging faster. And finally, communication. To learn effectively, you need to say, I think it's this. I might be wrong. But if you say it out loud, if you write it in your notes, if you say it on Slack, you're attached to this and you understand better why you failed and you know better what you checked, then it's a scientific approach that you publish everything that you know. Otherwise, you're not a good scientist. You disappear. And it's the same. If you know something, publish it. Because in ideal world, of course, not in the real world, the science should work that somebody has a theory and publishes a paper, and then someone else wants to check it, so proposes an experiment and verifies it, and somebody else reproduces this. They all publish papers, and in this asynchronous and decentralized manner, the science is put forward. And that's the way to debug to take debugging as a collective effort. And also, to make it working, scientists shouldn't be awarded for the volume of their publications. They shouldn't. And that's the same in debugging. It doesn't matter how much you type on Slack. It matters if your observations, your hypothesis, push the effort forward. Maybe you were wrong, but at least you cut some branches. And there is one last thing that I want to remember. If you want, debugging was a very hard lesson, and the way to make sure that you understand well what you learned is to transfer the knowledge, is to tell it to somewhere else, to write a note on Slack, to tell it on a local meetup, to tell it over a beer to a friend. Why? Because that's the best way to make sure you remember it and you are faster to fix it the next time you can see it. Thank you. Now I'll answer any questions.
Thanks, that was great, and I could see myself in many of those situations there, so that was good. I wonder if as parts of this, because this is more formalization on top of something that we end up doing in a very natural way, so I wonder if we have anything to share about practices, more process things that happen in your teams related to that, like every situation like that, there is a post-mortem that people need to share if there are documentations that are taken around that. If for some kinds of bugs, the PR needs to like try to reproduce it in a test, or things like that were introduced as part of the culture of the team, as in a way for those situations to help avoid them in the future. Which kinds of things in more process are taken that work for the team that you work on, that you could suggest for other teams as well?
So the question is more about the processes on the company level that a manager could introduce and that could be helpful. Of course, I do believe that postmortems are helpful, and in the company that I worked before, it was a big company, so we did have the rule that we have postmortems. Still, this rule is not enough, because you can write a real blameless but an honest postmortem that reads like a crime novel and everybody reads it, or you can be in a culture when your biggest concern during postmortem is that to put the blame on somebody else, not because you're a bad person, but because the company is so bad. So yeah, postmortems are a good idea, but you need a lot of cultural work around this to make sure that they are helpful. In a small company, I don't think you need a formal postmortem, but as I said, an internal rule, yeah, we screwed up, let's write it on Slack. I think it's enough. Would it help us to avoid problems in the future? For the same problems, probably yes, but the set of problems is infinite. So yeah, the thing that surprised me was that in one instance, I was watching a postmortem. It was the description of the problem, then actions taken, and then I was waiting for a long-term fix, and there was none. When I yelled around that there should be a long-term fix, the manager, who was a smart guy, said, And introducing a long-term fix would be too heavy for a problem that will not probably happen too often. So, and it was a good call. Instead of making the process very heavy to cover every corner case, we say, okay, we go fast. Sometimes we break things.
Did you consider writing a paper about this?
I would love to. You need to advise me where to publish it.
Okay, so if there's no more questions, folks, PhD of Bugology, Maciej Rząsa.